kind of want to start off with a couple kind of key things about today. Today's a remembrance, 75th anniversary, December 7th, 1941. Big impact on Boeing and manufacturing. Our first year as members of the IIC, we joined 1 year ago in December, so that's pretty exciting. And then I guess we're not as old as Bosch, that Dirk just, but 100 years old for the Boeing company is a pretty exciting thing. And so I'm just going to kind of go through a little bit of the history, some vision and strategy. So as chief strategist, you're going to get a little strategy here this morning. Talk about what we're doing to enable the factory today, what we're doing to enable the factory of the future, a little bit of the ecosystem plays, and then I'll close out with our challenges of cybersecurity and float that one up to the panel that's coming a little bit later. So this is me. So as part of our 100th anniversary, one of the things that Boeing is doing is they're encouraging everybody to kind of share their story. And so there's been some amazing stories this last year on what's been happening in Boeing and how it's affected. So I've been at Boeing for 32 years. I'm into my 33rd year at Boeing. Work on a lot of patents and different activities. There's my dad over there. He's going to be key to this story as we go forward. He's 83 years old. I like to travel. Those are my 5 kids. And in my spare time, I rebuild motorcycles. But really, the bigger story here is, so my grandpa, Orville Ray Nelson Sr., so I could have been Orville Ray Nelson III. I'm very thankful that my dad didn't pass that on. But he was working up the street here in Long Beach, and he had working on defense contracts to build ships up there in Terminal Island. And this was in the 40s. And so when my dad was 11 years old, they moved up to this place called Seattle in this little town called Renton because they had just built a brand new factory to build the B-29s. And so my dad was 10, 11 years old, came up, and his dad was working in the factory. And what my mom remembers is at that time, you know, the factories were all covered with camouflage and there were armed guards walking around, and it was a little different factory than we have today. My dad graduated from Renton. When he turned 18, he could then go work for Boeing. So he went over and he was a jitney driver to deliver parts through the factory. So you think an 18-year-old kid, and him and his best friend Wally Bigoff were driving parts trucks around and got into a lot of trouble. But in April of 1952, he was driving his jitney around, and his friend Wally said, "Hey, there's something going on across the street, and I got a buddy that runs the radio tower. Let's go see what's going on." And so they left their little job and ran across the street and climbed up the radio tower. And at that moment, Tex Johnson, anybody know Tex Johnson if you're in aviation? All right. So anyway, Tex was sitting inside the first, it was the YB for the B-52, and the radio said, "Bring these engines up to speed, take it down the runway, shut it down, and come back and we'll see how this thing's doing." And so my dad's sitting there listening to the radio operators, and Tex takes it down, and if you know Tex, he gets about halfway down the runway and he says, "This bird has got to fly." And off went the B-52, and he went for a little 2-hour ride. So that was a pretty amazing thing. And then anybody know what happened? So that was April 1952. Anybody know what Tex did in August 7th of 1955? Yeah, he took our, what was the Dash 80 at the time, which became our Boeing 707, and he decided to barrel roll that over Seafair in Seattle. And twice, yes. And our president wasn't very excited about that until and so he was about to get fired until the airline executive said, "Well, that's a pretty interesting airplane. If you could do that, maybe we should buy a few." And so Tex ended up staying at the Boeing company. So after that, I came to Boeing in 1984, and I started working a little bit later on the B-2 program. So that's where we got a lot of our feet wet on composites. Both of my brothers work for Boeing. My brother's a structural engineer. He's worked on the 47 and the 777. And then the interesting thing is now with the new 777X, both my brother is a structural engineer supporting that program, and a lot of the industrial internet activity that I'm doing is supporting that program. So things have all kind of come together. This is one of my favorite quotes, and this is also part of our history, is William Boeing, made this probably around 1930, so very much early into the thing that we are embarked as pioneers upon new science and industry in which our problems are so new and unusual that it behooves no one to dismiss any novel idea with the statement it can't be done. And when I think about that, I think we are there again, right? So when I think of the Industrial Internet Consortium, the Industrial Internet of Things, it's really, we're now chasing some of these things where, we're embarking as pioneers. And it's an awesome, exciting time. And we really got to go after those things that are gaps and we know can be done. So again, I told you as a strategist, I threw in our strategy slide for 2025. Couple things that are kind of key here. For years and years and years, our vision and strategy was to be, the best in aerospace, and we were always competing against the normal competitors to do that. Recently, we've added this "and," right? So, number one in aerospace, but also an enduring global industrial champion. So I think what that really speaks to is we're going after this industrial internet space, right? We've got some goals to build our services business like never before, much more of a global reach. So playing into what you're going to see around our factories is, think about that enduring global industrial champion. The other thing that I like is this whole idea about accelerated innovation. So as I show you what we're doing today in the factories and what we're doing in the future in the factory, it's really going to focus on that accelerated innovation and getting productivity. And then on the value side, the number one thing at Boeing, and you'll hear this at any of our executives talk, is safety. So the number one thing is making sure that our people are safe in the factory, they come to work, and they go home. So you'll see that as we go through. So last year, I believe this was, September of last year, our CEO, Dennis Muhlenberg, was presenting at the Society of Aeronautic Engineering, and he put up this chart, which was our competitors and potential partners. Anything interesting in that chart from aviation, from our kind of classic? So you'll see the normal suspects, right? Airbus, Bombardier, Lockheed, but then you see the Googles and the Facebooks and the Amazons and Elon with his SpaceX, right? So we're seeing that competition growing, right? So if you follow this, Amazon is going after delivery space with drones, right? Well, we deliver freighters that Amazon and that, so you start to see some pushing into these spaces, so this is a whole new world for us, right? And it's a challenge that's really pushing innovation inside the Boeing company to compete in brand new ways than we ever have before. So just kind of get the size of Boeing and the complexity of the manufacturing world that we live in. 291 million parts installed per year for the 737, right? 6 million parts to build each plane of a 47, right? A little bit of complexity when you think about the manufacturing process. I think a bigger thing here is, 800 suppliers contribute to each airplane. We have 20,000 suppliers in the Boeing company, right? So there's a big challenge for us as a very large manufacturer as we move forward, and you're going to see what our challenges look like. From the industrial Internet of Things, the areas that we're really focused on, obviously anything that we can do with data analytics, machine learning, deep learning to really drive improvements in our productivity. And I'll show you why that is so critical here in just a second. Advanced manufacturing and robotics. So I think that's been our biggest investment probably in the last couple years and probably going forward for the next couple years, and I'll show you some of those. But again, safety, quality, and competitiveness. So we saw the competitors. Safety is one of our core values, and then we've got to get that first-time quality out. Smart parts, this track and trace that Bosch was talking, Dirk was talking about from Bosch, really important, right? So smart parts, knowing where things are, being able to find the parts, have the right thing at the right time. We have a whole kitting concept that we have the right employees with the right parts, with the right training and the right certificate to do the right job at the right time, right? And that's really what the industrial Internet of Things brings us. Also a lot of massive, large-scale data capture and visualization. So a single flight can create up to 0.5 terabyte, right? So a ton of data that's coming in. We have to have the ability to ingest all of that. Right now, frankly, in a lot of the areas, we have more data coming in than we can actually ingest. And we call that digital exhaust, right? What's the stuff that we can't actually get in and do stuff with? And then the other thing, there is a lot of work moving data from the core to the edge. And there actually is an edge-to-core activity going on within the IIC that we're participating in. But it's about where do we do an analytics at the right point, at the right time, for the right efficiencies to get the benefits out that we need. And then a lot of work within the mobile solution and device integration space, and I'll show you that in a minute. Opportunities, again, safety, that's always going to be number one. The quality, I'll show you some examples of that, but being able to, do the job the first time and not have to spend all the time with inspections and quality is key to getting us to the rates that we need to get to. And then competitiveness, so improved productivity, more efficient. So we showed this last year kind of as our big picture of how we think about IoT in the domains. So today we're talking about enabling this smart factory down here on the left. But we also have this 20,000 suppliers, right? So we have a huge supply chain that has to be feeding the factory. And then once we take that plane or Tex flies that plane off the tarmac, right, it becomes part of the operational environment. So we talk about smart connected cars where we're going to have smart connected planes, right? And what does that really mean? So as you bring these things together, a lot of our work going forward is around the concept of digital twin and digital thread. So we've been working with the Air Force. They had their initiative back, I think, in 2012 around digital twins, just to lower the recurring maintenance cost for the fleet. But we're really looking at making digital twins of our factory, through our supply chain, and of our assets as they fly away, right? And then the key thing is we got to connect these domains together. So how does the thread go from the supply chain into the factory to the flyaway so that an MRO somewhere that's working on a plane already has the digital blueprint that came from the factory? So this is really key to our strategy going forward. So I'm going to move into kind of where we are today and then where we're going. So has anybody been to a Boeing factory? Awesome. Awesome. So this is the 737 factory. That's the closest to home. This is the one that my grandpa in 1944 went up and started working in. It's the same factory, a little bit bigger than it was then. So we have some big challenges, right? This is our baby. This is where we produce most of the planes in the fleet. So the 737, right? This is the most efficient assembly line in the world. And we currently roll out 42 planes a month. We're going to 52. We put that plane together in 9 days from start to finish, right? And there's a video if you later want to click on that, and it'll walk you through 9 days of getting that plane together, right? But think about the efficiencies and the things that need to happen in order to move that rate from 42 to 52, right? So how are we going to enable that to happen? And not only the 737, but in the middle of that factory, we also added a new line, which is the 737 MAX. So we're not only producing the classic 737s, but we're producing a whole new generation of airframe. So this is our challenge. So some other very interesting things that are going on. This is around our 787-9. So we have a facility in Salt Lake City. It's called West Jordan, and they're doing some pretty amazing things as far as factory automation and enabling the future. The first one down here on the left is they build the horizontal stabilizers, right? So if you look at the back end of a plane, you've got your tail, your vertical stabilizer, and you have your horizontal stabilizers. So they build the horizontal stabilizers for the 787-9. Painting was a area where we had a lot of chemicals, people getting sick. It's a very hazardous thing for our employees. So the first thing we did is we implemented robots to do all of the paint and spray for the horizontal stabilizers. That increased efficiency, 60% of the paint process. Can anybody guess how much of the hazardous material was reduced for the employee? 100%, because they were no longer in there painting the stabilizers. So a huge win there was not only the efficiency, the quality, no rework, and then great for the employee not to have to deal in that environment. After they did that work, then they brought in Butch and Sundance. So anybody know the names Butch and Sundance from, yeah. So this is in Utah, right? So Butch Cassidy and the Sundance Kid. So they named the two robots that are actually building up the stabilizers, Butch and Sundance. And they can now build these horizontal stabilizers in 3x the time with first-time quality. They actually are the first ones that do the drill, they do the countersink, they fill it with the fastener, they inspect that it's, so they do the quality check all in one pass, right? So you've got the whole thing end to end. So that is a huge win. And then the nice thing is when you talk to the 30-year paint guys or the people that were putting in the fasteners, they're now the guys that are running the robots and running the paint. And so it's a pretty exciting time. The other thing is back in my hometown there in Renton, where the 737 factory is, one of the things we've got is the panel assembly line. So this is a 60-ton, 20-foot tall machine that basically puts the wing panels together. So if you look out, anybody fly a 37 down here on a local little hop to get down here? Yeah. So if you look out on the wing, right, so you've got the upper and lower panels, and actually inside the wing is the fuel cell. So that has to be a total sealed unit, right? And so what PAL does is PAL puts those panels together and seals it all, and that's part of our process both for the 737 and for the 737 MAX. So what you're starting to see is a lot of this automation on the floor to improve the safety, improve the quality, and then get us to the rates that we need to get to. So that's what we're doing today. Now, if you start to look out at where is the future going, anybody know anything about the TX trainer? All right, so for the Air Force, their trainers, I think, are very long in the tooth, and they're looking for a new set of trainers to train the pilots before they go and fly the F-18s and the F-35s, right? So they need something a little, you know, this is your, when I was taking driver's training in high school, right, they gave us the little Chevy Novas, and before we went off and had our car that we could do some damage with. So it still has the V on the back, and it's very nimble. So Boeing and Saab put together the TX trainer with some of the new advanced manufacturing. So the interesting thing about us building the TX trainer is, as part of the proposal, we delivered 2 real, fully functioning aircraft, right? Not prototypes that we have to break and test, and these are actually fully functioning. No tooling, right? So a whole new design methodology where we don't have to build up the whole set of tools, and a lot of the parts are built with advanced manufacturing in polymers, right? So they're printed and put together for the trainer. So this is a vision of how we're going to start to do this with the full, you know, model-based design, model-based manufacturing, quality review, and then moving forward to the flyaway. So thank you, Kathy. Another interesting area is we have a whole smart factory team, and this gets much more into the digital twin, digital thread side of the world, right? So we have, again, we talked about these 20,000 suppliers. So a lot of the work that we're doing going forward is to take those model-based definitions, and we're working with all the standards committees to start to be able to pass what we're doing on our design side, in our CATIA systems, and pass those down to our manufacturing sides to pack that into quality and drive it all the way through. So we built a smart manufacturing viewer, and it's looking at all of the data that's coming out of the factories as we start to wire all these factories up with advanced manufacturing. And we can look across all of our factories and see how things are going forward. And then down here on the right, you'll see some of the digital design and digital thread as we go through around the airframes, and this is one of our drones. The other thing is a lot of work in additive. So Boeing has spent over 20 years working in the additive manufacturing space. So this is not, additive is not a new thing. We've been doing it for a really long time. Just recently, working with Oak Ridge National Lab and Boeing, we printed the largest part that's ever been printed in the world. So this was a carbon fiber ABS part. It's a tool that we're using for the 777X, and we printed that part. And I think the key thing is kind of the whole messaging of enabling the future is that that tooling would normally have taken 3 months for us to design the tool, send it off, have it constructed in the normal way, ship back in order to be ready. And we've got that from 3 months down to 30 hours. And if you watch that video, you'll see the entire 30-hour print job done in 30 seconds. So, you know, it's this kind of thing where you see, you know, this, the Oak Ridge Labs, you know, they have a, I think it's called BAM. It's, you know, it's the big, I don't know, additive manufacturing. So some very cool things that are happening in that space. The other thing we're doing a lot of work in is AR, VR, and mixed. So also on the factory floor, to take all this data and make that readily apparent to the people working on the factory floor so that they can do their jobs. We've got a lot of spaces, like I was talking about that 737, inside those fuel cells. You've got no room to pop up your, you know, cell phone and look at your instructions for the next set of work instructions. So if we can have displays where you can get those work instructions so that we've got areas where you can do that hands-free, again, that's safety and that's quality. The other thing is we're doing a lot of work, especially around the HoloLens, for training. So the training now, if anybody's had to take maintenance training for Boeing, a lot about is death by PowerPoint, and you're in class for a very long time, and then you have to actually go out to a physical airplane to get certified. So if we can bring that airplane into the classroom through a virtual reality or augmented reality, huge savings and huge time for those that are getting trained. So this is the one that I said I would put in. So my peer, who's the chief strategist for security, wanted to make sure that we kind of teed up the security panel. So Stephen Whitlock passed this on to me, and a lot of areas here with just the proliferation of devices, the proliferation of data, right? The age of the internet and all these things jumping on the internet, and the internet wasn't actually designed to do a lot of the stuff that we're asking it to do. The complex systems that we've been talking about, and then the advance of cyber attacks. So I'm sure that the panel will have the answers to all of this by the time we get done. So I appreciate that. So what I want to kind of wrap up with is that as we start to imagine the future. So has anybody been up to the Everett site? Yeah. Did you go on the tour? Yeah. So the Everett site is the largest facility in the world. So it's number one by volume, usable volume. It's 4.3 million square feet, right? That's where we put together the 4.7 originally, and that's where we're doing a lot of the 8.7 work. We've just spent, over the last year, $1 billion building the 777X Composite Wing Center. That's a fully automated part of the factory, and it's an additional 1.2 million square feet. So one thing you guys can solve with Internet of Things is the parking at Everett. Now that we've reduced the footprint for the factory, we've increased that, the parking in Everett is almost impossible. But with that 1.2 million square foot composite wing center, I was just up there last week, it is an absolute amazing facility. So the wings on the 777X are going to be full composite. It's going to be the largest wingspan of any airplane we've ever built. So a single wing is 110 feet. So the other thing that we got another world record for is we built the largest enclaves to bake those wings in once we lay up the composites. And so those are 120 foot. We have 3 enclaves in that composite wing center to bake those wings, and AGVs to move those wings after they were automated, laid up the skins and put in to bake. Yep. And so it's a pretty amazing facility. It's kind of the whole future. The thing that we're working on right now really is around, as we automate these entire factories, how do we tie all these systems together, and how do we get that vision of the digital twin and the digital thread really to be a reality as we go forward. So again, super exciting time to be in this space. And again, what I'm excited about is, you know, we at this day are pioneers embarking on this new science and innovation, and there's nothing that can't be done. So thank you.